Here we're going to do an example of an indefinite integration, but we're going to use an initial condition to come up with a function that doesn't have some arbitrary constant, but in fact a specific constant that's added to it. So we know that, the standard thing that we know from this is that the integral of r prime of t dt is it's antiderivative plus some sort of constant. So this is a known situation. But what we want to do is we want to find the specific constant that satisfies this initial condition. So again, we're going to be solving for what this value is to fit these cases. This is a very common situation in physical systems. So then if I want to integrate r prime of t, with respect to t, then what I get is I get nothing in the I case plus t cubed in the j case plus so that was 1/2, it goes to 3/2, so you multiply by 2/3, so you have 4t to the 3/2, k. But we have some sort of constant. And so we can think of those as sort of like being a C1, C2, and C3. So instead, it's probably better to go ahead and write that as C1i plus t cubed plus C2j plus 4t to the 3/2 plus C3k. And it's probably also better to write this not only as 1 plus 2j, but 1 plus 2j plus 0k. Now, why am I doing that? I'm doing that because what I know is that r of t is this, but we haven't solved for what C1, C2, and C3 are. But we know a little bit. We know that r of 0 equals two things. If I plug 0 into this, I get C1i plus, that goes to 0, C2j, and that also goes to 0, C3k. So I know not only does it equal this, but it also equals 1i plus 2j plus 0k. So in general, if this was R1 or something, we might have to work a little harder for it. But these disappeared because t was equal to 0. So we know these values have to match. So C1 equals 1, C2 equals 2, and C3 equals 0. So what we can do then is take this equation and the fact that we know these values, and we can write our final answer as r of t is 1i, so it's I, and t cubed, so we use this equation is the one we want. C1 is 1, t cubed plus 2j plus, so we have 4t to the 3/2 plus C3, which is 0. So we can just leave that off, k. So the way we would make sure that you might say, all right, are you sure I got this right? Well, if I take r of 0, that's I plus 2j plus 0k. So I feel good. And if I take r prime of t, that's 0I plus 3t squared j plus 12 over 2, or 6t to the 1/2. So that's really 6 square root of t k. So I have, these are things that I've computed. They match the givens. So we can be reasonably confident that we have constructed the correct answer.